Evaluate the integral from minus infinity to plus infinity of 1 over 4 plus x squared dx if it converges. If it doesn't converge, it diverges. We want to prove that it diverges. So this is our first example where we have both of the bounds being infinite. We are in the second case. Both a is equal to minus infinity and b is equal to minus infinity. And so in one of these types of cases where we have infinities in both slots, we have to break this up into two separate integrals. What we're going to have to do is we're going to have to write this as the integral from minus infinity to some number up here, plus the integral from that number to infinity, 1 over 4 plus x squared dx. So these two slots, I've left them blank so far. It doesn't really matter. We can use any number, and any real number, not plus or minus infinity, of course, to substitute in there, as long as it's the same number in both places. We're just breaking up our integral at that point. Some people would do this just by using a placeholder called a. I like to be a little bit more definite when I'm doing things, so a very natural place to break this is going to be 0. Basically, what our function looks like is something like this. So we are finding the area under that curve, if that is a finite area. Okay, so what we're going to have to do is we're going to have to look at each of these two separately. So looking at this first integral, let's call this a. Looking at integral a, integral from minus infinity to 0 of 1 over 4 plus x squared dx. So we're going to replace minus infinity with something that we are going to take as, let's use r here. The limit as r goes to minus infinity of the integral from 0 to r of 1 over 4 plus x squared dx. So when we take the antiderivative of 1 over 4 plus x squared dx, we can do it with a tangent substitution, or it's a good one to just know off the top of your head. It's going to be 1/2. Let me write this down. Limit as r goes to minus infinity of 1/2 times arctangent of x over 2. Because that 4 is a 2 squared, so that's where that 2 and that 2 are coming from. Okay, plug in 0, plug in r. So limit as r goes to minus infinity of 1/2 times arctangent of x over 2 minus 1/2 of arctangent of r. So we just have to evaluate, what mistake did I make? I forgot to plug in that 0 right there. So what's arctan of 0? What's arctan of r? The limit as r goes to minus infinity of arctangent of r. Well, let's go to a new slide and just draw out a picture of what does arctangent look like. So there's going to be asymptotes, horizontal asymptotes at pi over 2 and minus pi over 2. And so what do things look like? It looks something like this. So we can see that the limit of arctangent as x goes to infinity, limit of arctangent x as x goes to infinity is pi over 2. Limit of arctangent x as x goes to negative infinity is negative pi over 2. And we also see here that arctangent of 0 is 0. So let's just squeeze in our answers here at the bottom. So arctangent of 0 is 0. Minus 1/2 arctangent r. R is going to minus infinity. So that's going to be minus pi over 2. So minus 1/2 times minus pi over 2. And so our answer here for our first integral, integral a, is going to be pi over 4. Okay, so now we have to do the second integral. Let's say this is integral b here. So this should be a very similar calculation. we're looking for the integral from 0 to infinity of 1 over 4 plus x squared dx. And let's plug in an r for that infinity and take a limit. We already know that antiderivative, so let's just write that down. So this all should feel very familiar. Plug in 0 and r, so our next line, limit r goes to infinity of 1/2 arctangent of r over 2 minus 1/2 arctangent of 0. Okay, so what do we end up with here? The limit is r goes to infinity of arctangent r over 2. That's going to be pi over 2. So 1/2 times pi over 2. Once again, arctangent of 0 is 0. So our answer is pi over 4. And so combining our answers, we get pi over 4 here. We get pi over 4 here. So pi over 4 plus pi over 4 is pi over 2 is our final answer. Okay, so how do we do this kind of problem? Let's just recap. If we have limits, if we have a and b are both infinite, minus infinity and positive infinity respectively, we have to break it in the middle at some point and calculate out two separate indefinite integrals. If either one of these diverges, overall integral would diverge. In this case, they both converge, so we just simply add our answers together to get our overall answers. One last thing that's worth noting here in this problem is that it is not good form. So every so often in this section, I think more than maybe other sections, I have to say what to not do. And the thing that we don't want to do is the limit as r goes to infinity of minus r to r of 1 over 4 plus x squared dx. So you might think that this is equivalent to what we did here. I mean, limits r goes to infinity of minus r to r, and because both of those are going to be infinite. It looks like we're doing the same thing, but we're actually not. So to kind of illustrate that, let's think about, if I asked you for the integral from minus infinity to infinity of x dx. And so if we sketch out what's going on here, we really see that this integral should diverge. That the integral over here on the positive side is going off to positive infinity. The integral over here on the left is going off to negative infinity. We want to say that this should diverge. Diverges. So a wrong solution would be to do this exact thing up here and say that this is the limit as r goes to infinity minus r to r of 1 over, sorry, I'm doing click at this problem here, x dx, limit as r goes to infinity of x squared over 2, plug in minus r to r, limit as r goes to infinity of r squared over 2 minus r squared over 2, and that's 0. And so this makes it look like it converges, but based off of our definitions, we want to say that this diverges. So don't do this. If you have both infinity and minus infinity as your bounds, break it up and do those separately.